I'm using
Are you
the
gonna
table,
PA?
whatever, because these tables are actually movable.
Yeah.
I think. I don't know.
Yeah,
This is weird thing. Oh, it's electrical.
It was like
That's what it is.
3 positions.
Why
Well,
is that
yeah,
there?
no, she was gonna try it. There's a guy that wants to switch to a different time and take shooting this time.
Oh, gotcha.
I already got it. 8 a.m. 21. Are you team? Are you? Oh, you're doing 17?
No, 21 on Friday.
Friday. We're Tuesday at 8. He's Friday at 8. Well, we'll let you know how it goes, I guess. There you go.
Are you doing the health sciences one?
No,
Oh.
I couldn't do any of those things, so I just have one to do.
The way Oswald was saying it sounded like you had to be a female to
No,
do it.
5 years.
So last
Like,
year
is
they
that-
got
is that
like burned
okay?
on Title IX stuff or whatever.
Like, oh yeah, you took it though, right?
So now everybody has to do
Yeah,
Title IX
5 years ago. Like,
Yeah,
I'm not
what
joking
do
when
you
I'm
take?
saying
So,
5 years.
today.
I mean
Oh, you're doing it
5
today.
years ago.
Yeah.
He's like,
And
oh,
so
man,
his
I
idea
took
was
my
since
time.
they're all freshman
Nice.
female classes, so
very
I
good.
want to put
And
a
I was just like-
male
And I was like
tier
reading
because
because I'm like,
something
oh,
might
it's not
happen.
super
Okay,
easy.
but-
But I'm like, I don't know how
Really,
well I can
just tell them.
teach it.
I mean, I understand health sciences are predominantly female, but it does not mean it's only females in there. What about that one lone
I was like,
male
a tutor,
nurse?
You know, like intro to organic at BSC. So I was like, I can tutor people.
Is he good
They
against
have to
Title
question
IX?
it.
Yeah.
How
I'm worried about the class, like, question, like, class or something. Yeah, I haven't taken my class for like 2 years. So here's the tutoring facility.
The only downside to the room, no whiteboards really.
I don't know. We'll try several options. And then if I have some secret writing, I can put it in.
The test answers.
Huh?
The answers to the tests.
Something like this, yes.
I know you went. Lansing. Oh, yeah.
What's
Cool.
her name?
Ian Bird. Yeah, do you know Dan Lansing?
Probably. Where's he
He's
from?
from Great Rock. Oh, yeah, no, it's in Minnesota.
No, what? Minnesota?
Yeah.
P-O-L-E-N-S-K-Y?
Oh, Lansing.
A-N or E-N? Because I'm an E-N.
I think it's an A. Yeah.
I know there's a few different ones.
Okay.
Because there's a...
Okay, well, thank you for coming again and not stopping your physical chemistry on last time meeting. So, who we are and what are we doing? So, I believe it is still a physical chemistry class. And where did we stop last time? On coming here and getting general ideas what are the objectives of the class, which would be something like getting principles for electrons and ions moving in molecules and staying together for stability and physical properties. And the motion of electrons doesn't follow our intuitive expectations from macroscopic world. Therefore, we need to look in more details on principles, how the electrons are moving in molecules and what is going on. Okay, and some of you have prompted me that there is a duality, that photons and electrons share properties of particle and a wave. So in order to be able to tell something about electrons on more quantitatively, we need to be able to speak about waves and wave processes on a math language. So we need to recall, develop, or find out how to deal with waves. They're more challenging than regular like point charges or like objects in our macroscopic, typical objects in macroscopic world. So we will cover some basic ideas for any wave, and then we will go deeper into electrons. So, what is a wave? Just some. Do not hesitate. It's not.
I don't know if that's a good question, but it has like typically an amplitude and like some kind of frequency.
You are speaking about harmonic wave, but the wave doesn't need to be harmonic. So the most typical answer that comes out at this question, everyone is hesitant to speak something out, to be caught on being wrong, and therefore. Any other definitions?
An oscillating form of energy.
One can imagine a wave with constant energy. But something is oscillating. It's good. So, what about throwing Hound in the last episode of Game of Thrones throwing stones at Wichts, and one of the stones was falling down on ice. But if there would be no ice, there would be like water. What happens if stone falls into water?
Ripples.
Huh?
Ripples.
Yes, and they are also waves. And you cannot exactly tell what are their frequency or wavelengths, right? But something wavy in nature is going on, right?
Mm-hmm.
So we are coming to thinking or defining what it is. So some of you told the word oscillation. So it is something developing in time, but also it is something distributed in space. So a wave is something that connects space and time. So one of the definitions, or one of the possible ways to speak about waves, there are several options. I'll try first here on the screen, maybe it will work better. So you see, if we do have some distribution in space, but think about one-dimensional, do you see it well? Maybe this finger all the time. And then, after some delay of time, we have the function with the same symbol, but the structure will be repeated at some elongation. So t is time, and x is position. So same function. So if you have some crazy distribution in space, and after some time it travels and reproduces the same shape, but at different location. So perturbation of something, we are not yet specific. For example, it could be surface of whatever, lake or swimming pool, and the shape is repeated. This is a good definition of wave on mathematical language. So a function that is repeated after some times in the same shape and at a little offset. So if we accept this, if you accept let's see if one can finger something there. When there will be time for presentations, you will be able to practice same, to enjoy the same technology yourself. So if you accept this type of mathematical definition, how would you discriminate between waves traveling in different directions? Like wave can go left or right.
Change the minus to a plus on the
Yes,
time.
yes. Yeah. So you can have left and right wave, or forward and backward. Good, good. Now you are certified experts in waves. But we have a few other things for you. When you did right, the easiest thing while talking to the waves is something periodic, something harmonic, which is much easier than waves of arbitrary shapes. And in most of applications, one speaks of harmonic waves. If you are not dealing with explosives, shock waves, which are exotic to the majority of the waves that we consider will be some sort of periodic or harmonic. So then you design a function that will repeat itself if you are offset either in space or in time. Maybe you can even tell it as a definition. So periodically repeats itself. Now it needs to be tick in space and time. Well, if it will be too hard, I will go to the old technology. And periodic means repeating the same shape. One of the examples is trigonometric functions, right? I do not have a language to explain it. It seems evident, but we need to pronounce it together. So, like, if you draw, some of you told that there is an amplitude, frequency, and if it is a wave periodic in space, then one can measure if it is periodic, then there is a period. Distance between repeating units. How would you call it? Did I wrote it? No. Okay. So if there is a length of wave, so for this lambda, what would you call?
Wavelength.
Yes. If something repeats yeah, we shouldn't dance here. Wait, I don't know. There is no fifth floor, but maybe there are some
Perturbations.
perturbations, or I don't know, maybe martial arts class.
Big birds.
So, if it is periodic in time, then between the same instances, like the harmonic function comes to the same amplitude, we can stopwatch time between these periodic events, and then we can call it. You can call it
A period.
yes. But then we can stick it, this harmonic function with two types of argument into the same functional form as we collectively designed as a group of intellectual activity people on the last slide. So function repeats itself if there is an offset in time and in space. So we set up this function as a sign of argument that shows us shift in space and thing that gives us shift in time. Right now, we did a very important thing, but intellectually it doesn't go beyond high school program. We will develop a little bit further, I promise. So what is the goal? Well, I know the goal is for me to finish the class and get more free time, for you to get great and also get more free time. But locally, right now, if we need mathematical laws for motion of electrons, and before we go into this, we need some principles to describing wave motion. What can we always tell? Hey, our electron is cosine. I'm not sure if you can tell it in public. Even if sometimes it could be correct in very limited cases, but you cannot do this way. It will be very non-genuine. So typically, the wave is a solution, but one needs something that generates them. A wave generator in mathematical sense. So
Function.
Huh?
Function.
No, function is a wave, but not generating function. It's a different chapter. Typically, the functions come out of solutions of differential equations. So we need some equation by solving which we will get a wave type of solution. We are not in math department. We are not in math class, so we should go relatively easy without too much stress, but some minimal effort cannot be avoided. So we are not going to derive, but we are going to guess an equation that will generate waves as its solution. Objections? Motivation is clear? Okay, so we will guess such equation by, and we are not going to solve it ourselves for most of the cases, but we will not make the rigorous proof, but we will try to make it clear case, come to such levels that no one objects or no one tells that I suspect it is wrong. So in order to come up with an idea of what could be the, let me write it down. So the goal is equation. And if it will be equation to generate waves, it will be wave equation. So in order to come up with this idea, we will do two mathematical experiments. So one mathematical experiment, I know you didn't came here to study math, but it is so simple and enjoyable that maybe you will forgive. So what if two waves are colliding? What is going on? What do you expect to happen?
One of two things: constructive or destructive processes.
Yes. Yeah, that's so correct that even poor. I was expecting. I was expecting some wrong answers that would sound exciting, like a wave would scatter from each other and go in the opposite direction. So, suppose we have localized waves, not as a infinite periodic function, but like short wave packet train. Two of them collide, and what will happen after they pass? Will they change or not? So some of you prompt that they will not change, and it is again so right boring. There is in basic wave processes there is a well-believed principle of superposition, which means if you add together several waves, they just are constructively or destructively added, but they do not affect each other. So there are no non-linear phenomena. It's all linear. And we are going to make this experiment by adding together two waves that travel opposite directions, by having different sign in their arguments. How would we do it? mathematically. How would we add two cosines?
Use a trig identity.
Mm-hmm. Do you remember?
I
I don't. I have a cheat sheet, but I
don't know.
let me guess and then look into the cheat sheet. But maybe some of you were studying well in other classes and can guess it well. So,
It's like the cosine of the first one minus the second one or something. I don't remember.
like, I'm so lazy that I would die to rewrite this cosine and all these arguments. Let's write down as C sine alpha. But I'm not guilty. It's a technology. If it will fail, I will write here. But it's so impressive to. Beta plus cosine alpha minus beta. Where this alpha and beta are those time and space.
I could pull out my phone.
Dang it. I have it. It's at home.
If I were working in the math program right now, it'd be a cheat sheet I could just look at.
Probably one can recall equations for those expressions separately and then add them together. So I will do my best. Yes, alpha plus beta could be. And later, if you need it in class, I do have algorithm how to rederive these equations. I cannot recall anything, but I know how to rederive it within 10 minutes, which we do not have now. Therefore, I'm guessing. So cosine alpha times cosine beta plus sine alpha times sine beta. And cosine alpha minus beta will be cosine alpha cosine beta minus sine alpha sine beta. And if I'm not wrong, by adding these two together, one will get the addition of two cosines on the left. Then, and on the right, these two terms will repeat because they are the same. 2 cosine alpha cosine beta. And these two cancel because they have opposite sign. Does it sound legitimate to you?
Well, I found the correct one.
How wrong am I?
Well, it should be, let's see, 2 times the cosine of, let's see, wait, how are you starting this? Because the alpha and beta are different here, I think, between what you got and what they've got.
Well,
But yeah, that's more or less correct, because it's the cosine alpha plus cosine beta is 2 cosine alpha plus beta over 2 times the cosine alpha minus beta over 2. At least that's what this
so
picture is saying.
what I'm worrying about, are there here both cosines or there are two different functions?
They're definitely both cosines.
Okay, so if you find any mistakes in the lecture, write it down, print, and you will get extra credit. So let's put it in constructive way. Okay, what do I have in my? Either I was wrong by preparing cheat sheet, or I was well, it was consistent. Either mistake here and there, or correct here and there. So if we plug into this shorthand notation our 2 colliding waves, instead of summation of 2 waves, one will get product of 2 waves. So cosine of this space part and cosine of this time part. What does it mean? How do we interpret it? Now we are coming again back into high school program in science. Like the wave in this form was a running wave. This maximum and minimum were traveling. one way or another way. But when they collide, we do not have difference, we have product, which means we do have this time, the space-dependent part, but the time-dependent part serves as its amplitude. So the same shape, just changing, lower or higher, right? So we have the shape corresponding to the spatial part, but at next time it will be a little lower amplitude, then a little lower amplitude, and then it will get negative amplitude. Right? No objections. This will be our f capital of x and t, and this will be x. So you will see that, well, here 0 was 0. You will see that there are points that you have always 0 amplitude, and there will be points where the amplitude is changing. So does this wave travel anywhere? Well, can we tell that this wave is can we name it as traveling wave? It's not the best name because it looks like standing somewhere. If it is standing, then how we call this wave?
Standing wave.
Good. What else? I want to be lazy. I just I don't mind to be. So writing long equations is always boring. Why don't we call the spatial part as x capital and time resolved part as t capital? Just if I have another attack of laziness, I will use these notations instead of writing long equations. So this will be x capital, this will be t. Good. How are you doing this time? I'm not yet on the. Okay, good. So same thing we already covered. So by looking different fractions of period, we will get different amplitudes, and there are other points. Excellent. We are done with mathematical experiment number 1. Who we are and what we are doing. We are trying to come up with well-argumented, although not rigorous, derivation of an equation that will generate waves. And we will come to this equation by making 2 numerical experiments. First was to explore superposition that sets up a bridge between traveling waves and standing waves. And second experiment will be to practice derivatives. Why? Because differential equations always have derivatives. We have a big hope that derivatives help us to solve everything. It's answer. No, I should hide it. Probably I will do something here and then open the cheat sheet. Yes, direction. Okay, so we are going to practice. Well, I'm going to practice. You probably will just glance and even have no notes or no report. But you're always welcome to take notes. So we are going to practice derivatives over time and space of this standing wave. And there are expectations that we will come up with some really good, I just don't want to talk with you, really helpful conclusions. So our function is product of